Good morning children, I am Mrs. Senir Karasi. Today we are going to discuss chapter 5 Language of Chemistry. So in this chapter we are going to learn symbols of elements, ions, valency, naming of compounds, formulae of compounds. Symbols of elements. You know that till date it was found that 118 elements were known at till date, and it is hard for us to memorize the name with correct spelling, and it is inconvenient for us to use the name of the element wherever it is necessary. So that's why scientists introduced symbols to represent an atom of an element. So a symbol represents one atom of an element. For example, capital H, it represents one atom of hydrogen. Na represents one atom of sodium. So therefore a symbol represents one atom of an element. So John Dalton introduced pictorial symbols to represent elements. So he is the first one to introduce symbols, specially used pictorial symbols. So he represents the elements with picture. For example, you can see the picture. Hydrogen means a circle with a dark spot at the center, and a solid circle represents carbon, and a plain circle represents oxygen, and a circle with capital I represents iron. So these are the pictorial symbols introduced by John Dalton. But this is also inconvenient for us to use because look at the gold. We need to draw a circle and we need to have 8 dots, and in the center we need to have a capital G. So this is also inconvenient for us to use. So it is easy to spell the gold, G-O-L-D. So pictorial symbols also inconvenient to us to use it wherever it is necessary. So that's why J.J. Berzelius introduced modern symbols. So he suggests that we can use the English name or Latin name of the element to derive the symbols. So he said that we can use the first letter of the English name of the element, and it should be written as a capital letter. For example, hydrogen, the first letter is H, therefore symbol of hydrogen is capital H. Oxygen, the first letter is O, symbol of oxygen is capital O. Carbon, the first letter is C, symbol of carbon is capital C. So is it possible for us to have the first letter for all the 118 elements? Definitely not, because we have only 26 alphabets. So therefore, he also suggests that we can use one more letter along with first letter, and that letter should be written as a small letter. So first letter should be capital letter and second letter of the symbol should be written as a small letter. For example, calcium. So first letter and second letter is used as a symbol, capital C, small a. Zinc, first letter and third letter is used, capital Z and small n. Chlorine, first letter and third letter is used as a symbol, capital C, small l. So this is how symbols were derived from the English name of the elements. And he also suggests that we can derive the symbol from the Latin name of the elements. So few symbols or few elements are derived from its Latin name. For example, here also first letter we can use, or along with first letter one more letter can be used. So one letter symbol and two letter symbol we can use it. So look at the example, potassium. The symbol of potassium is capital K. It is derived from the Latin name kalium. And symbol of iron is Fe. It is derived from its Latin name ferrum. And the symbol of lead is Pb. It is derived from its Latin name plumbum. Okay children. So symbols are derived from its English name or from its Latin name. You can use the first letter of the name of the element, or else we can use one more letter along with the first letter. So one letter symbol, two letter symbol we can use. So first letter should be capital letter and second letter should be small letter. So that's about symbols of elements. So next we will see about ions. So what is an ion? How an ion is formed? Classification of ions. So let us discuss one by one. Ions. When an atom loses or gains electrons, it becomes a charged particle called ion. Suppose if an atom loses electron, then it becomes a passively charged ion. It is called as cation. For example, Na plus, Mg 2 plus, Al 3 plus. So these are all cations, passively charged ions. Cations. And if an atom gains electron, then it becomes a negatively charged particle. It is called as anion. Anion means negatively charged particle. Look at the example, Cl minus, O2 minus, N3 minus. So negatively charged particles are called anions. So how a cation is formed? By losing electrons. How an anion is formed? By gaining electrons. So now let us look at the formation of cation. How a cation is formed. Sodium. So 1123. Electronic configuration of sodium is 2, 8, 1. And we want to know how many electrons it want to lose or gain. So it will be followed with the help of a rule, octet rule. So what is an octet rule? Every atom want to have 8 electrons in its outermost shell in order to achieve the most stable noble gas configuration. For example, neon is a noble gas. So its electronic configuration is 2, 8. So it has 8 electrons in its outermost shell, and this is the most stable electronic configuration. So therefore every atom want to achieve the same electronic configuration of noble gases. So therefore sodium want to lose 1 electron, because if it lose 1 electron, its L shell is the outermost shell and it already has 8 electrons in it. So therefore sodium loses 1 electrons. So now what happens? So look at the sodium atom. It has 11 proton, 11 electrons. You know that proton is a positively charged particle and electron is a negatively charged particle. So therefore plus 11 minus 11 is equal to 0. So atom is electrically neutral. And now sodium loses 1 electron. What happens? Now its electron becomes 10 electrons. It already has 11 electron. It loses 1 electron. Now it has 10 electrons. So therefore plus 11 minus 10 is equal to plus 1. So now the sodium atom attains a positive charge. Plus 1. It attains a positive charge. Sodium converted into sodium ion by losing an electron. So this is how cations are formed. So let me take one more example. Magnesium. So the electronic configuration of magnesium is 2, 8, 2. So total number of proton 12 and 12 electrons. So plus 12 minus 12, that is equal to 0. Magnesium atom is electrically neutral. So look at the electronic configuration. How many electrons it want to lose? 2 electrons. So then only it can able to achieve the noble gas configuration. Neon configuration 2, 8. So magnesium loses 2 electrons and it forms magnesium ion. So plus 12 proton minus 10 electrons. Therefore plus 2. Magnesium attains 2 positive charge. So magnesium atom by losing 2 electrons forms magnesium ion. Okay. Okay. So next we will see how anion is formed. For example, chlorine. Chlorine, the electronic configuration of chlorine is 2, 8, 7. So according to the octet rule, it should have 8 electrons in its outermost shell. So now chlorine want to gain 1 electron. So if it gains 1 electron, it becomes 8. Yes. So chlorine atom has 17 proton, 17 electron. Plus 17 minus 17 is equal to 0. So now it gains 1 electron. Therefore 17 electron becomes 18 electrons. Plus 17 minus 18 is equal to minus 1. So chlorine attains a negative charge. So chlorine is converted into chloride ion by gaining 1 electron. Okay. One more example we will see now. Oxygen. Oxygen. Electronic configuration of oxygen is 2, 6. It has 8 electrons. 8 proton, 8 electron plus 8 minus 8 is equal to 0. Oxygen atom is electrically neutral. So in order to have 8 electrons in its outermost shell, it need to gain 2 electrons. Therefore, it gains 2 electrons. Now 8 electron becomes 10 electrons. Plus 8 minus 10, that is equal to minus 2. Oxygen attains 2 negatively charged ions. So oxygen is converted into oxide ion. It gains 2 negative charge. Okay, so now how ions are classified? Ions are classified based on charge, based on number of atoms. So already we know that based on charge, they are classified into cations and anions. Cations means positively charged ion. It is formed by the loss of electron. Anions means negatively charged ion. It is formed by the gaining of electrons. So example, already I told you, Na plus, Mg2 plus, Al3 plus. Cations example, anions, Cl minus, O2 minus, N3 minus. So these are the examples of anions. So based on charge, ions are classified into positively charged ion, cation, and negatively charged ion, anion. And based on the number of atoms, they are classified into monoatomic ions and polyatomic ions. Monoatomic means, mono means one. So one atom, the ion should contain one atom. Look at the example, one sodium atom, one magnesium atom, one aluminum atom, one chloride ion, one oxide ion, one nitride ion. So one atom. Therefore, these are all monoatomic ions. Polyatomic ions means group of atoms. So look at the example. Ammonium ion NH4, group of atoms, totally 5 atoms, 1 nitrogen, 4 hydrogen atom, totally 5 atoms. So group of atoms. So it should be polyatomic ion. CO3 2 minus, carbonate ion, sulfate ion, nitrate ion. These are all polyatomic ions. So based on number of atoms, ions are classified into monoatomic ions and polyatomic ions. And based on the valency. So valency means the combining capacity of an atom. So based on the valency, ions are classified into monovalent ion, divalent ion, trivalent ion and polyvalent ion. Mono means 1, di means 2, tri means 3, poly means many. So these are all the numerical prefixes which was used in chemistry. Chemistry la irukkakudiya numerical prefixes mono, di, tri, poly. And monovalent means valency is 1. So Na plus Cl minus, that means 1 electron is lost or gained. 2 electrons lost or gained. So monovalent ions, Na plus Cl minus ions are examples. Divalent ions means valency 2. Mg2 plus O2 minus. Trivalent ion means valency 3. It loses or gains 3 electrons. Al3 plus N3 minus. Polyvalent ion. So here I have given tetravalent. 4 means tetra. So Pb4 plus and Sn4 plus. So based on the valency, we can able to classify the ions into monovalent ion, divalent ion, trivalent ion and polyvalent ions. Okay, now we will see how to name an ion. How to name an ion, naming of ions. How to name a cation. So it is very easy to name the cation because just we are using the name of the element and ending ION. We want to add ION. Sodium means sodium ion. Magnesium, magnesium ion. So just name of the element we are going to use and at the end we are going to add ION, ion. So naming of cation is very simple. Naming of anions. So name of the element by changing its end. So what we are going to do? We are going to use the name of the element but we are going to change the end. So for example, if the anion is in elemental form, so element mattu irukano, elemental form, element oxygen, chloride, hydrogen. So elemental form la irukumbodhu we need to use the ending IDE. So look at the example, Cl minus, the chloride element is there. So chloride ion, O2 minus, oxygen element irukku. So oxide ion. So the ending should be IDE for the elemental form. Suppose if it have lesser number of oxygen, the ending should be ITE. And if it have a greater number of oxygen, the ending should be ATE. So look at the example, NO2 minus, NO3 minus. So compare these two ion. So here greater number of oxygen, 3 oxygen. This is lesser number of oxygen, 2. Therefore lesser number of oxygen, the ending should be ITE. For greater number of oxygen, the ending should be ATE. This is nitrite ion, this is nitrate ion. Likewise, sulfite ion, sulfate ion. So 4, greater number of oxygen, 3, lesser number of oxygen. Therefore, it is a sulfite ion, this is sulfate ion. So based on the number of oxygens, we want to use the ending. Okay. And for elemental form, we want to use IDE. So anion should be named by changing the end of the name of the element. Ending should be changed. Okay. Okay. So next, what is valency? The combining capacity of an atom of an element is known as its valency. So look at the example, water, H2O. Oxygen is combined with 2 hydrogen atoms. Therefore, the combining capacity of oxygen is 2. That means valency of oxygen is 2. And magnesium chloride. Magnesium combines with 2 chloride atoms. So that means the combining capacity of magnesium is 2. That is valency of magnesium is 2. So valency is nothing but the combining capacity of an atom of an element. Okay, the number of electrons donated or accepted is its valency. So in the terms of gaining or loss, sorry, the number of electrons donated or accepted, based on that we can also calculate the valency. And it also depends on the number of valence electrons. So what is valence electron? The electron which present in the valence shell. Valence shell is the outermost shell, and the electrons which is present in the valence shell is known as valence electrons. So valence electrons, based on the valence electrons, the valency can be calculated. Variable valency. What is variable valency? Some elements have more than one valency. They are said to have variable valency. For example, there is elements with more than one valency is written as the name of the element followed by the Roman number. For example, iron has more than one valency. So it can either lose 2 electrons or it can lose 3 electrons. So the valency should be indicated in the bracket as Roman number. Iron 2 means the valency of iron is 2. Iron 3, Roman number 3. Iron 3 means the valency of iron is 3. Copper 1, copper 2. So the valency should be indicated as a Roman numeral in the bracket. Okay, and then we want to indicate the valency is indicated with the help of a Roman numerals, and naming should be changed. So suppose a lower number of valency, the ending should be written as OUS. So copper means cuprous, lead means plumbus, iron means ferrous, and higher number of valency ending we want to change it as IC. Iron, ferric, cuprous, cupric, plumbus, plumbic. So lower number of valency, the ending is OUS. Higher number of valency, the ending is IC. Okay, so that's about valency. So now we will name the compounds. How can we name a compound? So ionic compound means definitely it should have a cation, then followed by anion. So cations naming already we know. We want to use the name of the element. And anions naming also, now only we seen it. So name of the element, and we want to change the ending. So we want to use IDE, ITE or ATE. So look at the example MgO. So Mg magnesium, O elemental form, therefore IDE we want to use oxide. Magnesium oxide is the name of the compound MgO. Na2SO4, Na sodium, SO4. It is a higher number of oxygen, greater number of oxygen, therefore ATE we want to use sulfate. Sodium sulfate. Na2SO3. So oxygen 3, lesser number of oxygen, we want to use the ending ITE. So sodium sulfite. Okay, while writing a name of a compound, the cation should be start with capital letter. Magnesium, capital M. Anion should be start with small letter. Oxide, small O. So capital letter you want to start, and anion should start with a small letter. Magnesium oxide. Okay, so this is how we want to name a compound. Suppose if more than one atom of an element is used, means we want to indicate it by its prefix. For example, CO, one oxygen atom is there. Next compound CO2, two oxygen atom is there. PCl3, 3 chloride ion is there. And CCl4, 4 chloride ion is there. PCl5, 5 chloride ion is there. So more than one atom if it is present, means we want to use the prefixes. 1 means mono, 2 means di, 3 means tri, 4 means tetra, 5 means penta. So likewise we want to use the prefixes. CO, carbon monoxide, CO2, carbon dioxide, PCl3, phosphorus trichloride, CCl4, carbon tetrachloride, PCl5, phosphorus pentachloride. So likewise we want to use the prefixes. Okay, so now we want to write the formula of a compound with the help of a criss-cross method. So what do you want to do? In step 1, to write a formula of a compound, 3 steps you want to follow. In step 1, you want to write the symbol or formula of the given compound name. And step 2, you want to write the valency. And in step 3, we want to interchange the valency and we should write them as a subscript. Okay. And if it is needed, we want to simplify the formula. Wherever it is needed, we want to simplify the formula. So let us look at the example. Aluminium chloride. So first up, what we want to do? We want to write the symbol. Aluminium Al, chloride Cl. In step 2, we want to write the valency. Valency of aluminum is 3, valency of chloride ion is 1. So in the next step, we want to interchange the valency. So valency of aluminum is shifted to chloride ion, valency of chloride ion is shifted to aluminum, and the valency should be written as a subscript. So valency 1 should not be indicated because it is written 1 times. Therefore, AlCl3 is the formula of aluminum chloride. So calcium oxide. In step 1, we want to write the symbol. Calcium Ca oxide O. Both the valencies are 2. So in step 2, we want to write the valency 2, 2. And in third step, we want to interchange the valencies. Ca2, O2. Already I told you we need to simplify wherever it is needed. So common terms means we can able to cancel it. Therefore 2 1 is 2, 2 1 is 2. So it is enough to write 1 times. So CaO is the formula of calcium oxide. The next example, magnesium hydroxide. Symbol of magnesium Mg, hydroxide ion OH. Next step, we want to write the valency. Magnesium 2, hydroxide ion 1. So in the next step, we want to interchange the valency. So magnesium should be written 1 times and hydroxide ion should be written as 2 times. And we need to use a bracket while if writing a polyatomic ions if it is more than once. So if the polyatomic ion is more than once, mean we need to use a bracket. Okay, so magnesium 1 times, hydroxide ion 2 times, therefore we need to use a bracket and then we want to write the valency as a subscript. Okay, so magnesium MgOH twice is a formula for magnesium hydroxide. Then ammonium sulfate. So formula of ammonium is NH4, sulfate SO4. Valency of ammonium is 1, valency of sulfate ion is 2. So we want to interchange the valencies. Ammonium we want to write it as 2 times and sulfate 1 times. So more than 1 times means you need to use a bracket. Therefore NH4 enclosed with a bracket and 2 times should be written as a subscript. Then SO4 1 times we want to write. Therefore, formula of ammonium sulfate is NH4 twice SO4. Okay. Okay. So then, what is the importance of chemical formula? Why we are writing a chemical formula? What is the importance? What informations can be able to derive from a chemical formula? Number 1, it represents the name of the compound. So by looking at the chemical formula, we can able to tell the name of the compound. MgO means magnesium oxide. NaNO3 means sodium nitrate. So we can able to derive the name of the compound with the help of a chemical formula. Number 2, it represents one molecule of a compound. So a chemical formula represents one molecule of a compound. H2O means one molecule of water. MgCl2 means one molecule of magnesium chloride. And 3, it indicates the elements constituting the compound. So what are the elements present in a compound can able to easily we can able to find out by seeing the formula. And it also tells about the number of atoms of various elements or ions present in one molecule of a compound. For example, H2O. So by looking at the formula, we can able to tell what are the elements present in this compound. For example, in water, it has hydrogen and oxygen. So these are the two elements present in water. And we can also tell the number of atoms. Water contains 2 hydrogen atoms and 1 oxygen atoms. So likewise sodium nitrate. So what are the elements present in sodium nitrate? Sodium, nitrogen and oxygen. Then how many number? 1 sodium, 1 nitrogen, 3 oxygen atoms are present in sodium nitrate. Thank you children.